First lesson, parts of an atom. You guys have probably already heard this many times. Don't trust atoms, they make up everything. So atoms are made up of three subatomic particles. Those are protons, neutrons, and electrons. And they each have a distinct mass, a location, and charge combination. So protons, those are the things in pink, have a mass of 1, and they are located in the nucleus. They have a positive charge. Neutrons are also located in the nucleus, and they also have a mass of about 1, but they have no charge. They are neutrally charged. And then electrons have a mass of 0.001. I call them the eyebrows of the atom because they have mass, but they are virtually massless. So if you stood on a scale and took your mass, then shaved off your eyebrows and took your mass again, you would be taking stuff off, but you wouldn't be able to see that on the scale that you have. So none of our balances really record the mass of an electron. So we call them the eyebrows. They do have mass. So when your textbook says they don't have mass, I really take exception to that because they do. But they're whizzing around the nucleus. Crazy. Think about gnats in a cloud. Those are the little tiny insects. And they have a negative charge. So electrons are whizzing around. They're like gnats. They're like eyebrows. You can easily pluck them off if you want to. Whereas the protons and the neutrons are located in the nucleus. Now, just to give you a relative size thing, if the atom was the size of Gillette Stadium, a huge football stadium, that would be mostly the electrons whizzing around. The nucleus would be about the size of a golf ball in that huge football stadium. So relatively speaking, the volume of an atom is mostly taken up just by these whizzing around of these electrons, like the cloud of gnats, and really that nucleus is a really, really small part of that, although it contains most of the mass. So these three fundamental particles take up, they give us the characteristic of an atom. Now, the proton is the number one fundamental particle. In fact, they call it the fundamental particle. And it is the fundamental particle because it defines the atom. So if I change the number of protons, I change it into a separate element altogether. The atomic mass is the number of protons plus neutrons. So when you're talking about an atom itself, because you can only have a proton or a neutron, you can't have like half a proton or 3/4 of a neutron, your atomic mass will be a whole number. But the average isotopic mass, or the atomic mass, will probably not be a whole number because within an element, you can actually have a different number of neutrons, and because it still has the same number of protons, it's still the same element. Kind of like you can have apples of all different sizes, so the average apple mass might be different, not a whole number. Charge. If I have a different charge, I call it an ion, and the charge is determined by the charged particles, the protons and the electrons. So if I have an equal number of protons and electrons, which is assumed on the periodic table, my element is neutral, it has no charge. If I have more protons than electrons, I will have a positively charged ion, and I call it a cation. It looks like cation, but it's really cation. And if I have fewer protons than electrons, this will give me a negatively charged ion, and that's called an anion. If I have 2 more protons than electrons, my ion will have a positive 2 charge. If I have 2 fewer protons than electrons, then my anion will have a negative 2 charge. So the imbalance will tell you whether it will be a positive or a negative ion, and the magnitude of that will give you the charge. So just to go for your periodic table, in the entry of the periodic table, you will see a couple of things. So one is this big set of letters right here. It will always have a capital letter. In fact, you can always tell how many elements, different elements there are in a compound by how many capital letters. You just count up the capital letters. If there is more than 2 letters in the symbol, that second or third letter, because it can have up to three, has to be lowercase. If you are in the habit of writing things in all in uppercase, it's just that some of them are smaller than others, you have to stop that in chemistry. If you're talking about an element or anything else, if it has to be lowercase, it has to be lowercase. So just get into the habit of that. So this is the symbol. It will always have a symbol. Underneath the symbol, if you're lucky, it will also have the name of the element, and that here is zinc. So Zn stands for zinc. In the upper left-hand corner, or over the symbol, you will have a whole number, and that whole number is the atomic number. That's the number of protons. It will always be a whole number. In fact, if you are worried about which one is the atomic number and which one is the mass, the one that is always the whole number is the atomic number. So that tells you that zinc has 30 protons in it. All zinc isotopes have 30 protons. And then the number underneath it, in blue, 65.38, is the average isotopic mass. It's the mass of 1 mole of zinc atoms in grams. So it's the collection of zinc. So on average, most of them will have 30 protons and 35 neutrons, giving a mass of 65. But there are some zinc atoms that have more than 35 neutrons, so you might have a larger number, which is why, given the mixture, you have a non-whole number mass. So just to recap, there are 3 different subatomic particles: protons, electrons, and neutrons. Protons and neutrons together give you the mass. Protons and electrons give you the charge. And protons are what we call the fundamental particle. They define the actual element.